Okay, good afternoon everybody. I'm here to explain to you problem number 78. And if you look at problem number 78, you'll see that the given is that the compound contains carbon, hydrogen, and nitrogen, and there's 35 milligrams of this, and that it yields carbon dioxide, CO2, and there's 33.5 milligrams, and water, H2O, and there's 41.1 milligram. So to begin with, just like problem number 77, if you watch the video, we will follow the same steps, almost. Okay, so the first step is to find the percentage of carbon dioxide that is carbon, because if we find the percentage of carbon, we'll change it into grams, and how many grams is over here is going to be the same number of grams that's over there. So, and by the way, we also know that since this is a combustion, you'll also add some oxygen, and that's where the oxygen comes from. So, but continuing on, we need to find the grams of the carbon. So we're going to find the percent that carbon is out of CO2, and carbon is 12.01, and it's out of a total formal mass of CO2 is 44.01, and that percentage is 27.3%, and then that's 27.3% carbon. And then we'll go ahead and change this percentage into grams, so we'll get 27.3% of the whole, 33.5, which is 9.14 milligrams. And now we'll do the same thing to H2O. So we'll find the percentage of hydrogen, which is 11.11%, and then we'll multiply it by 41.1, and then that will give you 4.57 milligrams. Yes, 4.57 milligrams of hydrogen. Okay, now using these two, using the law of conservation of matter, we know whatever is on this side is going to end up on this side. So we know that there will be 9.14 milligrams of carbon on this side and 4.57 milligrams of hydrogen on this side. So let's go ahead and write that down. So now we know how many milligrams there are in carbon and hydrogen. Now we want to find how many milligrams are in nitrogen. So out of the total of 35, we're going to subtract 9.14 from it, and 4.57, and that is 21.29. Now, this is the grams of each one of C, H, and N. And now we want to change it back to moles so that we can write the empirical formula. So to change to moles, we can remember that moles equals grams over formula mass. Moles equals G over Fm. So we'll divide each of the grams by the formula mass respectively. So that's 12.01, essentially 1, and nitrogen is 14.01. And then your results are 0.761, 4.57, well, it's 1.01 is actually the formula mass of hydrogen, so it's 4.52, and then 14.01, it becomes 1.52. So again, we just divided the grams by formula mass, and this gives us each of the mole ratio. Now, again, this is a ratio of the moles, so we need to find the smallest number, and we need to divide everything else by it. The smallest number happens to be the 0.761 right here. So we'll divide everything by 0.761. So that will be 1, 5.96, and 2. The 5.96 we will change to a 6 because the 0.04 400th is just rounding error somewhere in the problem. So then we have the ratio of 1 to 6 to 2. So we have CH6N2. So CH6N2 is our final answer for problem number 78. Hope you enjoyed. Bye!